so what's coming in 2.2? So one of the big things in 2.2 is concurrency. A lot of improvements in concurrency. 2.0 had a lot of improvements. 2.2 actually resolved a lot of the issues that people were having. And 2.2 should have a lot more. A couple of big ones. So one is DB level locking. Take a step back for a second, actually. It's hard to describe what locking in Mongo is, right? If people think about what it actually is, it's not DB, DB level locking in Mongo is not like, my ISAM. Anyone here ever use my ISAM in MySQL? 500 people. So the deal with my ISAM and MySQL is that it's collection level locking. But basically, if you do a query that takes 5 minutes, well, nothing else can operate while that's happening. You have exclusive access to that table for 5 minutes. Locking in Mongo is very different. So all Mongo operations are interleaved, right? It's kind of, if you think about sort of a single thread, if you think about a system with a single thread where everything's just interleaved, right? So think about like a Node.js style application where it's you have a single thread and everyone's just interleaved. That's sort of more the way Mongo is designed. It's actually not using a single thread, but it probably could be, or using a small number of threads. And the idea is that basically everything's time sliced. So there's two different aspects of it. There's three different aspects to it. There's how many different locks are there, is how good the time slicing is, and this how good time slicing is relating to disks, right? The key for a database, and especially, the key for most databases is that you never want to hold a lock while you're touching disk. Disk access is, way slower than RAM. And so you want to make sure when you're doing your time slicing that you're time slicing around disk access. So there's two things we're doing in 2.2. One is DB level locking, which basically means that the time slices are around DBs, not around the server. So that's a big step forward. The biggest issue is actually, so you can do some crazy things and actually put different collections in different databases and do all sorts of hacky things. But the real benefit of DB level locking is that replication uses a different lock, right? Replication is like a regular Mongo query basically, and it stores data in a collection, and it uses that collection for doing all of its syncing and all that sort of stuff. And so now that it has an isolated lock, replication isn't really impacted by database operations. So that's pretty good. And you could do other things too. But the big thing in 2.2 actually, that actually will really help performance is yielding with disk access, which basically means making sure that when we do time slicing is completely aware of what's going on in the RAM, and what's in RAM and what's on disk. And that if you're trying to do something that's going to touch disk, that you do not hold the lock while you're touching disk. And so there's so in 2.0 we started working on this, and we did a lot of work on it, and we hit a few of the key pain points. And for those key pain points, it made a big difference. What we did in 2.2 was very different. Using the exact same underlying system for tracking and synchronizing our knowledge of what's in RAM versus what's on disk, we're actually at a very low level basically aborting operations when they try to touch disk and hold a lock. So basically there's literally code at the very lowest level of the system that says, hey, I'm trying to access a record. If this record is in memory, great, I'm going to let you continue. If this record is on disk and you haven't modified anything yet, I am actually going to abort you and say, no, you have to restart, and before you restart, make sure you load this disk location off of disk and put it into memory. Sort of a simple concept, but the benefit is that at the end, you're really never touching disk in a lock, which basically you're bound by, mostly by RAM, which is really what you want to be, not bound by disk speed. So it's actually a pretty big change. The other two things we added are related to this, which is that you can actually measure page faults by database, which is pretty cool. So if you've got a bunch of different databases, you can actually measure exactly what's going on, which database is causing page faults and all those interesting things. And you can measure number of page faults that caused operations to get aborted. And if we did miss a case where we can't abort something, you'll be able to see very clearly how many page faults happened with the lock being held that for some reason we were not able to abort the operation. Well, that's great, because then if you see those, you can tell us and we can fix them. And it's great because you can actually very clearly see exactly what's going on in terms of the disk subsystem, which is pretty cool. I think it's like this is stuff I wanted in MySQL a long time ago, but never had. So this is pretty cool. So that's concurrency changes. The next big thing in 2.2 is the aggregation framework. So obviously a few talks on it today. But the basic idea for those who don't know is that being able to do simple aggregations in Mongo pre-2.2 is too hard. Right? If you remember, one of my design goals was that I want aggregation to be simple. With MapReduce, MapReduce is not simple, nor easy, nor fast. So it sort of fails on all fronts. It's good for certain things, but it's not awesome. And we want something really good. And we want something awesome too, I guess. So what does it look like for those of you who don't know? So let's say you've got a collection of blog posts, and blog posts have an array of tags associated with them, and you want to compute a simple tag cloud. Now this is all you have to do. Before you'd have to do a MapReduce job, you have to write JavaScript inside of your Python code. It's a big mess. Now you just say unwind tags, which basically means explode the tags array, and then count tags, basically do a group. So for each tag, for sum of, plus equals 1. Very simple, very short. If I actually had the MapReduce code up here, it would be very hairy and very messy and not very pretty. So this is much nicer and a lot faster as well. So that's really quite nice. Next is TTL Collections. So TTL Collections and 2.2 are going to be fairly straightforward, and they're actually things you could implement on your own. It's just nice that the database does it for you. Basically, let's say you have sessions, and you want sessions to automatically expire when they haven't been updated in a day. So all you have to do at this point is say, create an index on last updated, and set the flag expires after seconds, which is 86,400, which is how many seconds there are in a day. You set that flag, everything else is taken care of for you. It's basically like a background job constantly deleting things. So it's always very incremental and very fast. Now the big problem with this kind of workload, if you get sort of a high insert, high delete workload, is that you can get fragmentation. So there's some stuff we did for this, and basically if you use TTL collections, it automatically configures the collections in ways such that it's impossible for them to get fragmented. Seems like a cool feature, maybe we should expose it. So we did that too. So fragmentation, like any storage system, is definitely a problem. The reason why it's a problem is that the storage system tracks free space in buckets of power of 2. Right, so there is a list for each power of 2 up to 16 megabytes that stores areas on disk that are free. So if you've got records on disk that are 513 bytes or 713 bytes, well not 513, 613, 713, 813, 913, they're stored in the same free list. So now let's say you've got something really ugly. You insert 1 million documents that are 600 bytes. Then you modify every one of those 1 million documents, and now there are 650 bytes. Those 1,600,000 byte locations are now sitting on a free list. Now you go ahead and modify a few more things from your 650s. And now you try to go insert something that's 700 bytes. Well, your 600 byte records are too small. You're never going to use them. Big problem. So there's a lot of ways to solve this. So what we're doing in 2.2 is actually, it's not on by default, but it's an option that you can turn on whenever you want. You can turn it on for old, if you upgrade to 2.2, you can turn it on for old collections as well. And basically what it says is, anytime you allocate space in this collection, allocate it up to the power of 2. So never allocate 713 bytes, always allocate 1024 bytes. So when you delete it, you always have 1024. So in the previous example where you inserted 1,600,000 byte records and delete 1 million, you have exactly 1,000,1024 byte records. If you go insert something that's 813 bytes, you can take one from there. So it's pretty good. So there's basically no way you can get unused fragmentation. Now that you can have wasted space if all of your documents grow from 813 to 1,300, but that's not really the common case. The common case of fragmentation is where you've got these little holes that you can't use because things just don't fit anymore. Now obviously this will use about 50% more disk space on average than not using it. But the benefit is that so in the short term it actually seems like it's more expensive, but in the very long term, if you have a lot of fragmentation, you actually end up wasting a lot more than 50%, and you get some performance degradation. Whereas this way, performance is always going to be fairly consistent, right? You're never going to get a drop off, and the wasted space is fixed. Whatever you have at the beginning is what it's going to be forever. So it's much more predictable, and predictability generally trumps most other things in my mind. So that's that. There's a lot more stuff we want to do later, but this is what we're doing for 2.2.